past. So I'm recording this lesson as of now. And I'm going to put that within an hour after we finish this class. Remember, uploading it to YouTube takes a little while and stuff. So, okay, everyone. So quick reminder, we have here reminder number 1. Remember, we have our weekly math quizzes. It's going to be pretty one-dimensional, no pun intended, this time around because it's going to be on surface area, which I think is it's such an important topic. It's going to come up so many times in geometry. And we're going to be talking specifically about surface area of cuboids. Okay? So what I would want for you all, and remember, we like to take notes when we're in live class because it adds to the notes we already have. And this is no different. So let's go ahead and talk about this. When I ask you all, what is a rectangle? I bet all of you think you know the answer to this. Okay? And I'm gonna go ahead and I'm gonna fill you in so that I can be mindful of time. And by the way, moderators, when there's about 3 minutes left for the end of class, so very roughly around 9:13 a.m., please let me know. Okay, so when I ask you what's a rectangle, I bet you all probably think that a rectangle is this figure, right? It's basically kind of like a square and kind of not, because these two sides are congruent with each other, and then these two sides are congruent in length with each other. But not all the sides are equal. That's probably what you think about. But did you know that a square is also a rectangle? Where all the sides are congruent and all the sides form right angles? And the reason that that's the case is because the rectangle, in the purest definition, is basically a figure that is like the first one I drew, right? Where two sides are congruent at a time and the other two sides are congruent. And also, it's also a figure like a square. That makes up the realm of the rectangle. The thing is that when we talk about a figure like this one, the square that we normally refer to, is the reason that we don't call that a rectangle is because it's more specific to call it a square. And the first figure, which is the way that you think of a normal rectangle to look, right? We call that a rectangle because that's the one that's not the square, the one that has only two sides that are congruent in size. But I want to go ahead and I wanted to make that clear because it can get confusing in geometry in the future and now, that when you think of rectangle, it's actually the whole thing. The same way that an ellipse is everything that is a circular two-dimensional shape, and the special type of ellipse, and we know this from Khan Academy programming, a special type of ellipse is one where the length and width is equal, and that's a circle. And we don't really have too many circles in our world, perfect circles, I mean. Okay? So that's the same idea. So a rectangle is it's also square and also the way that you think of a rectangle. And I say that specifically because of this new vocabulary word that might be a little weird for you, cuboid. A cuboid is, and this is the part where you should definitely write it down, right? It's a three-dimensional solid with 6 rectangular faces. Okay? And all of those rectangular faces are at right angles to each other. Okay? So a cuboid is, and I'm going to go ahead and zoom over here if you don't mind for a second. This is a cuboid. But a rectangular prism, so if that doesn't look like a rectangular prism to you, if that looks like a cube, then fine, okay. But a rectangular prism is also a cuboid. So cuboids, you guys, are both. It's the big, huge umbrella category for rectangular prisms. You know, 3D rectangles. Rectangular, hold on, let me make sure that I spell this right. Rectangular prisms. and also traditional cubes, right? The little perfect little 3D squares. Yeah, that's what cuboids. So cuboids are both those things, or better said, both those things are cuboids. It's just like a really fine and easy way of saying rectangular prisms and cubes, which, let's be honest, they're related. So cuboid is to 3D what rectangle is to 2D, is my whole point with this. Okay? And let me know if that's okay by just commenting yes on the comment box, because that was a really important point that I just made right there. Okay, and if it's not okay, one of the moderators will let me know. The next key cons. Okay, it looks like it's fine. Great, great. Okay, so let's move on. So the next key concept, and I'll keep this all, I'm going to try and keep it all so it's still, you can all see the first key term. The second thing is a key concept, and that's surface area, and that's what we're going to be working on today. So, surface area. This is an important term. I didn't mean to scratch that out. Yeah. So surface area is basically to measure the total. It's measuring the total area of the outermost layer of a 3D solid. Okay? I was explaining this during office hours on, I think it might have been Thursday or could have been Thursday. And I said to somebody, look, do you all remember when we were doing volume, that it's like measuring everything that is inside of a 3D solid, like the full space, if you will, instead of a 3D solid like a cube? Well, surface area is the exact opposite. It's like measuring the layer of paint that you add on the surface all around a 3D solid. Okay? So if I take this cube and I paint only the outer layer, all that area that I fill in on all of the faces of all the sides, right? The faces, that right there is the surface area. So now we're measuring the full outside of something. And just to be clear, what we're really doing here is we're getting the area of all the sides and we're adding them together. That's really what surface area is. So I get the area of this face and then the back face, the two side faces, the top and the bottom face. Get all those areas and add them together. That's area. And the last thing I want to say about that is that we're actually measuring the same way that this is how area works in two-dimensional figures. We're getting the 1 by 1 unit squares. We're finding how many total 1 by 1 unit squares comprise the entire shape. Okay? And in this case, it's for 3D solids. All right. Does anybody need any more time with this first slide? I know that I was moving kind of quickly there. And if you need more time, just let me know with a yes. Okay, great. Yeah. So while we have that time, let me go ahead and review what I just said because that was a mouthful. Okay. So the first thing I said was that a rectangle includes a square and also the standard rectangle, which is counterintuitive because we probably haven't been taught that much. The second thing is that a cuboid, and this is important, includes a cube and a rectangular prism. It's like the encompassing term for cube and rectangular prism. And the one of the last things I said, the last thing was that surface area, which is the point of today's lesson, is like if you put a layer of paint, like if you paint a cube You can only paint the outside layer of it, the outermost layer. That's what we're measuring. Okay, we're measuring only that. So if you need to, you can take a screenshot and we can move a little bit forward. And somebody had a question. Yeah. Yeah, that's what I want to do now. I want to move into that. Okay. Yeah, let's do it. Okay. So guys, take a screenshot if you haven't, and it'll help us speed us up. Okay. And I'll give you a couple of seconds for that, and we'll move into the first example. We're gonna fly through these guys. Okay. Okay, let's do it. Remember, this is being recorded, so I feel good about moving forward. Oh, not so fast. Okay. So here's our first practice example problem. I just want us to warm up with this. So pretend that we're just solving for area right now, because this is going to warm us up to surface area. So all we're doing is getting the area of the two-dimensional 2D square. And remember, the directions here say, okay, solve for the area of the 2D square above, and the length of that 2D square is 1 meter. So I wonder if you can solve for the area of that square if you just know that the length is equal to 1 meter. Okay, please no whistling. Thank you. Okay. So if you know that the length is equal to 1 meter, you know that the width is equal to 1 meter. No, it's a 2D square. Yeah. Joel, so let me finish talking about it first. Okay. So that being the case, area is equal to length times width, which is equal to 1 meter times 1 meter. And therefore, 1 times 1 is 1. That's a 1 there. Meter times meter is meter squared. Okay, so the area is 1 meter squared. Now let me add, now remember, all you guys just finished doing with me here, and I know you were probably just watching as I was doing it, right? But you just solved for the area, which we've done before. But what if it's not a square? What if it's a 3D version of a square, a cube? Can you solve for the surface area? Which means you have to get the area of one of the faces, which we just did, and add it by how many faces a cube has. Okay, in other words, 6, right? So what would the surface area of that figure that I just drew here be if it was a 3-dimensional cube and not just a square? Okay, Charlie, what's your comment? Surface area, yeah. So what we're doing, Charlie, is I'm warming you up to what this means. So I'm starting from the very ground. Okay. Orly, what's your question? It wouldn't be cubed. It's still meter squared. That's a really good question. So surface area is only squared. It's not cubed. Okay. I'm gonna say SA. SA. I'm gonna say that's surface area. Okay. It's squared. Squared units. Because you know why, Orly? Because it's area still. Okay. That's the important thing. So you guys, if you're trying to get the surface area of a cube that has these dimensions that I just did here, it would be whatever the area is, because it's a cube, right? It's the area times 6, okay? Or you can say the area added to itself 6 times. So what's that going to be? What's that surface? Good. 6 meters squared. Excellent. Okay. So, guys, so let's go ahead and move forward. Okay, are we ready? All right, here we go. So we're going to go ahead and we're going to move forward. I hope you guys got that, but in case you didn't, remember it's being recorded. And secondly, we're going to have more examples. So you're going to get it for sure by the last example. Oop. Okay, let's try this one. This is a rectangular prism, also a cuboid. As we know, the cuboid is the umbrella term. Solve for the surface area of this cuboid if given. Given is like a big term in geometry. Length is equal to 6 feet. Width is equal to 3 feet. And depth is equal to 2 feet. Right? So that being the case, can you solve for the surface area? And I'll give you a hint. If the length, which is this part here, is equal to 6 feet, okay? And the width, which is this part here, is equal to 3 feet. You're going to do 6 times 3 to get the area. To get the area of this face, the front face of this shape. Okay? And because there's a front and a back that is exactly the same area, you know, the back part back here, then you can do what area that area is. 6 times 3 is 18, 18 feet squared, right? Times 2. And now you have the front and the back face. But you still have to do this face, which is the same as this face, and the top face, which is the same as the bottom face. Okay? So I'm going to go ahead and I'm going to, just to save a little time, I'm going to go ahead and do this with you. So we did the front face, which is 6 times 3, which is 18. Okay? Feet squared. And we're going to do that plus 2 because there's a front and a back, and that's going to give us 36, and we're adding, right? So it's still feet squared. Okay, so we got that. That's the front and the back. Okay, guys, let's do the side faces. Okay, so the one that was here and the one that was here. So let's see. The width of this shape is 3, and the depth is 2. So 3 times 2 is 6. So it's going to be 6 feet squared because we're getting the area. Remember, now we did this. What we're doing is we're getting the area of this face here. But there's that side, and then there's this side that's here. If you remember, this face that's here. So it's going to be 6 plus 6. We get green again. It's going to give us 12 feet squared. And now we got to get the top part. Let me see, what color should I get for this. So the top face, which is this one here. Now, remember, the length is 6 and the depth is 2. So it's going to be 6 times 2, which is 12. Again, great. It's going to make it so much. Actually, not 12 again, just 12. 12 feet. And then the bottom is the same as the top face. So it's going to be 12 feet. Guys, make sure you check my math just to keep you active here. All right. So we have those 3 numbers. In the surface area, you have to add them all up together. Okay? So it's going to be 36 plus 12, which is going to be 48. So we did this one, we did this one, and now plus 24. So let's do, let me do it differently. So 48 plus 24. So yeah, it's a scam call. Don't like that. Sorry, everybody. Are you still with me? Can you moderators? Can you still see me? I'm going to start recording again. Okay, so I left off at 48 plus 24, and that's going to be 12. Carry the 1, 4, 5, 6, 7. All right, you all. If you did this ahead of time, if you got ahead of me, you should have got it 72 square feet. Can someone confirm that that's what we have? Just go ahead and give me like a yes if that's what you got to. Okay. Great. Oh, that's okay. Good. So if you got a yes, you're doing good. Remember, all you're doing is you're getting the area of all the sides and you're adding all those areas. And when I say sides, I mean faces, of course, right? And then you're adding them all together carefully. And remember, the unit, as Orly pointed out so astutely, is always going to be squared, right? So square feet, because it's still area. All right, let's move forward with this. I hope I'm not moving. I'm probably moving a little fast, and if I were a student, I'd think so. But remember, it's being recorded, so it's okay. Oh, cool. Thanks, Josh. Okay, guys. So try this one out. I made it a little bit trickier. It's a cube. I'll give you that, and that means that all the length, the width, and the depth are all the same, and that's x equals 3 millimeters. I wonder if using this information, you're able to go ahead and quickly solve for the surface area. Okay, try and give it a shot and see if you can pull it off. And I'll give it a shot too, and I'll move as slow as I can here. Okay, area equals length times width. And length is equal to 3 millimeters. And width is equal to 3 millimeters because it's all the same. Then area is actually 9 square millimeters. And that's just for like one face here. But there's not, it's a cube, right? So all the length, the width, and the depth are all the same number. And there's 6 faces. So a shortcut here for surface area is 9 times 6, because there's 6 faces. That's going to give me surface area 54. And it's going to be millimeters squared, always squared, because it's area, even though it's surface area for 3D shapes. Okay, so I went really quick on that one, but I hope that you were able to kind of see that when you have a cube, you hit the lottery, so to speak. It's like easy, I got this, because just go ahead and get the area for one face and then multiply it by 6, because the cube has 6 faces. All right, this one I'm going to give to you, I think. It's what I think it is. Yes, okay. Directions. This one you have to do. Find the surface area of this cuboid given. Length is 2 inches. Width is 3 inches. And the depth is 2 inches. Ready, set, solve. Okay, I'm going to work, but I'm going to go even slower than before, I think. Okay. All right, Mr. C, let's see here. Let's solve the first face, which is this one. And that's also the back face. So the front face is 3 times 2, which is 6 inches, square inches. And that's going to be plus the back, which is also the same. That's going to give me 12 square inches. All right, that's the front. Now the side face, there's two of them, one on the right, one on the left. It's going to be 3 times 2. No, this is going to be easy. So it's going to be 6, right? So 6 square inches plus the other side face, 6 square inches. It's going to be 12 square inches. And now, let's finish this up. The top face. Now that one is interesting. It's going to be 2 and 2. If I calculated that correctly. And that's going to be 4. 4 square inches. And that's going to be plus the bottom face, which is 4 square inches, equaling 8 square inches. All I gotta do is add these answers together. I know 12 and 12 is 24, and 24 plus 8 is going to be 32. No, 24 plus 8 is going to be 30. So it's going to be 30 square inches. So surface area goes 30 square inches. What's your question? Well, tell me something. Do the numbers go really high? Okay, Jules, so that's a really good question. And here's what I'm going to say to you. If the numbers go too high, yeah, use calculators. Yeah, like if you go past like 2, 3, and 4, like if you start getting to 6, that can start to getting like a little higher. If they use numbers like 14, like if like one like length equals 14, you can use calculators. I'll give you that permission, and here's why. I'm not testing your capacity to calculate right now. I'm only testing your ability to solve for surface area. Okay, so oh, okay, sorry, I made a mistake. So where did I make it? 24, 8, 9, 10, 11, 12. Oh yeah, it is 32. Thanks, you guys. Oh, okay. So you all, I accomplished my goal. I was able to go pretty far here. And the last thing I'm going to go ahead and say, for your IXL assignment, look at that, we did perfect. I'm requiring now, because I want to go easy on you all, I want to make sure that you have enough time to do all your homeworks. You can do 10 problems from IXL. And remember, just what Jules and I talked about, if it goes too high, and I want you to use your judgment, I'm trusting you, you can use a calculator, okay? And then you can do either 10 problems or 30 minutes, whichever comes first. That should be enough practice if you're staying on top of it. Okay, you all? If you want to stay for questions now, you can do that. And I'll let the rest of you go. Thanks for being awesome. Yeah, buddy, what's up? Yeah, and I'm expanding it. If you, 10 minutes? Did I put 10 minutes? Oh. So Charlie, make it 10 problems or 10 try and do 10 correct problems. Okay. Yeah, so you're welcome. And Charlie, thanks for that, buddy. I appreciate it. Let's make it 10 problems or 30 minutes. I'm clearing it up for you all. Okay? Thanks, Charlie. You're welcome. Bye. Bye, you guys. See you later. Anybody else here?